Hello everyone and welcome to the second part of the Tower Defense series, and we are gonna be making waypoints in this video. And what waypoints are is that they will move our creeps through a predefined path, because in the last series, or in the part 1, our creeps would only move from one side of the screen to the other. We want to change that so we can determine where we want the creeps to go. And I've made a small sketch here, and what you see here, these stars, that is what represents the waypoints. The red ones are the creeps, and the white arrow is the path it is following. And it's actually going to be very effective because we can set these waypoints in our storyboard and our creeps will automatically follow them. Now let's just jump right into it. I have my Xcode project here, and it is the same project that we made in the part 1. And if you remember what we did, all we did was actually just to make a creep class, and we could spawn those creeps and they would move on our screen here. And now we would like to make some waypoints, and the first thing we're going to do is to find something to represent our waypoints. Because what is a waypoint exactly? Well, a waypoint is just a series of coordinates. And what have coordinates? Well, everything on a view has coordinates. So we're actually going to use labels to represent our waypoints. And why we are using labels will become apparent in a second. We're going to use one here, call that one A, and that is where they are going to start. And then we want them to move just straight ahead for some time. We'll call that B. Then we would like them to go up to waypoint C, and then all the way over here to waypoint D, then down here to waypoint E, and then finish off at F. Now our creeps will start here, move over here, go here, then here, here, and here. And we will use the labels here because they all have a center property, and that property is a series of coordinates, and we're going to use those coordinates to determine where our creep are on the screen. But first we need some way of extracting the coordinates. So we are going to be making a outlet collection of UI labels. We're going to call it Waypoint Collection. And we want to add all our waypoints to this collection. So we have a way of extracting the coordinates. And there we go. Now we go into our view controller file, the game view controller, and we see it has the IP outlet collection. And now we want to create a way to sort our array of waypoint collections, because when we load in this collection it might put D as the first waypoint, and that would have our creep spawn here. We don't want that. We want them to be organized in a way that says A, B, C, D, E, F. So the very first thing we're going to do is create, make property on our view controller file, non-atomic strong. It's going to be an NS mutable array, and we will call it waypoint locations. Now this is going to hold all our waypoint locations, CG points values. Next thing we're going to do is go into the game view controller. We are going to be accessing a method called viewDidAppear, and what we want to do here is actually extract the coordinates. But first, as I said before, we need to sort the array. So we're going to make an NS sort descriptor. Just call it sort, and it is going to be an NS sort descriptor with key. And the key is a property on the objects that we are sorting. And UI labels, they have a text property, and the text property is what contains the A, B, C, D, E, F. So that's the property we want to sort, and we're going to sort them in ascending order, meaning that A will be on top and F will be in the last. What we want to do after the sorting is actually to sort the array, but we can't just sort the collection we've made here because it's just a normal array. We could change this just to be an indisputable array, but we're just going to create a new one here and call it Waypoint sorted, and it's going to be equal to the objects we had in our waypoint outlets, or our waypoint collection. So now we have a way to sort them. We have an indisputable array with the labels we want to sort. So now all we have to do is simply just call the sorting action sort with sort using descriptors, and you can see it takes an NS array. So we just need to make an NS array with object sort, and that's because you can add multiple sort descriptors to an array and it will sort using all these sort descriptors, but we only need this one, so this will do. Alright, so now we have our sorted array, and as you remember, we made this instance variable here, and that's actually what we want to hold the coordinates, but we can't just hold the labels. We're not interested in the labels, we're interested in the coordinates. So we are gonna extract those coordinates. We're just gonna create our instance variable because we can't really start adding objects if we don't. So what we're gonna do now is to enumerate through our waypoints, let me think here, waypoint sorted. There we go. We are going to enumerate through this one because it contains all the labels. And what we want to do here is extract the coordinates that the label has. So I'm going to make a CG point, and the CG point is going to be equal to the label centered property. Now we can't just store this CG point value back into this array here because CG point is not an object. You can see there's no asterisks here, so if we try to save this into our waypoint locations, we'll get an error. But luckily we can convert it to an NS value object, and we can make that an NS value with CG point and then our points. And now we can store this value into our array. And after we're done with that, we're just going to remove the label from the view, because now there's no reason for it to be stuck on the view. And after we're done with this, we just want to empty this collection here. Not the collection, the array we just made, but that's local, so Yeah, okay, I guess we're good now. There's no need to clean up because when we break out of this method, it'll all happen automatically. So what we have here, let's just quickly hoover through it. We're sorting our array of UI labels by doing this, creating a new array because we can't sort directly on the outlet collection. We sort it here. We set up our instance variable that will hold all the CG points of the UI labels, but they have to be converted to NS values because, or else they can't be stored back in an array. We add the value and then we remove the label from the superview. Well, that's basically it. Now we should have a list of coordinates in an array. And what we want now is to actually implement this sort of behavior on our creep. Now, this can be a little tricky, but basically what we want to do is that our move method, it should see whether or not it reached the current waypoint. And if it reached the current waypoint, we want it to get another waypoint and start moving towards that one. So in order to do this, we actually need to be able to have access to all these waypoints that we've created in the game view controller with this array here. And the way we're going to do this is to add some instance variables to our creep class, and it's going to be a CG point, and it's going to be named current waypoint. And the creep's going to be moving towards this current waypoint, but we actually need to activate it somehow because we need to give it this information, to give it these waypoints so that it can hold on to them itself. Alright, well, then we just create a property, non-atomic strong, NS mutable array, and waypoint array. We want to load all the coordinates into this waypoint here. And we can just do this in the init method. And waypoints, NS mutable array, VPS for waypoints. There we go. And we implement this behavior in here, and waypoints. So what this means is that when we create a creep, we pass in the waypoints for the creep. And we're going to do this by saying, we call it waypoint array. And we're just going to set it to point to, or to be a part of that. There we go. Waypoint array, and it's NS mutable array equals NS mutable array. What on earth? I totally forgot how we did that. We did it here. NS mutable array with array. Why won't it work? Let's just try it again. Waypoint array equals NS mutable array with okay, well, there we go. Array with array, and then the passed in array, which we call VPS. And now this creep actually has knowledge of all the waypoints. We just gotta fix it down here, and on initialize it's just gonna pass in nil. And that's all great, but we haven't really set the current waypoint yet. We need to set that waypoint so our creep will start moving there, and we want it to start at that location, because you can see we just set our center property of the creep manually here. Well, we want to set it to the current waypoint, and that starting location is going to be the first waypoint we have stored here. So let's go ahead and do that. And as you remember, we stored values, so we actually have to extract values as well. I'll call it point, and we are going to get the objects at index 0 from all the waypoints. We are going to set our current waypoint to be equals to point CG point value. So now we have converted it back into CG point values, and CG point values that have an X and a Y coordinate. And you can see it's the same here, that's the CG point. So all we have to do now is to set the center property to be equal to the current waypoint. And now we can actually remove this one, because now our creep should start at the first waypoint. Alright, so now we're kind of ready. Now our creeps should start that waypoint and they should move forward. Let's just take it for a spin and see if it works, because then they should be starting down there. And we have an error. Yeah. It was bad down in the view did load, where we are spawning all the creeps, and we changed the initializer method, so obviously we have to give them some points, and it's going to be waypoint locations. But this actually poses another problem, because view did load method is going to be loaded in before view did appear. So what we're doing here is that we're actually trying to spawn creeps before we have set this waypoint variables. And you might ask yourself, why we're not just doing this in the view did load method. Well, if we did that when we are extracting all the labels out and getting the center coordinates, it would actually be some weird coordinates, and maybe they would just be 0, 0, because in the view did load method they haven't really been added to the screen. They are just ready to be added, so they haven't been given a center property or a center value before we get to the view did appear method. So that's why we're doing the work in there instead. And we're just going to move all the work from the view did load to the view did appear method instead. Then take this for a spin. Take some time to load. Come on, baby girl. There we go. I'm just gonna flip it. Rotate left. Press play, and then they should start spawning down there. Let's see if it works. Well, what do you know? It works. Now that's great, but they aren't really following along the path now, are they? Well, let's just go ahead and fix that. We want them to move along that path. Alright, well, what do we have so far? We have a property that contains all the CD points. We have it down here. It contains all the waypoints. What do we have here? We have the current waypoint. Alright, so we need some way of checking whether the creep has moved to the current waypoint, and if it has, we need to give it a new waypoint. Okay, so we actually need a new method. We're going to call that next waypoint, and it's not void with a capital D. Alright, let's implement this method. And what this method is going to do is to get the next waypoint in the array. So we just do exactly the same as we did before. We get this waypoint. array object at index 0. We get the point from our waypoints. We convert it into a CG point and store it in our current waypoint, like this. And then we remove it from this array, because what happens here is that we will call this method when the creep has reached the waypoint. It takes the waypoint, it stores the waypoint into the current waypoint, and then it removes it. So you can see the pattern here that it'll keep doing this, get a new one, and then erase the old one. And this will actually enable it to move through our series of arrays. But there is a problem here, because we're not actually calling this method. And where would be a good place to call this method? Well, maybe in the move method, because the move method is actually the only place where we change the coordinates of our creep. So that could actually be a very good place to detect whether or not our creep moved to the new waypoints. So let's go ahead and rewrite this move method. First, we're going to create a new x and a new y coordinate for our creep. And we extract the old ones like this, center.y. And what we have here is we have two variables that each represent the current location of our creep. We could just keep doing work with this, but we use this for quicker reference, and it gives a better look to it. So what we want to do now is to see where the next waypoint is, compare it to where the creep is now, and then move the creep accordingly. For instance, if we have this, we can see where its coordinates are. This is at 442x and 224y. Okay, we're just going to move it back up here. If it moves over to, now it's at 533 and 139. And if it moves over to b, you can see that it actually decrements the x value. It gets lesser, but it has the same y value. Okay, so that means that if we are here, then we need to, and we want to get here, we need to decrement our x value. Alright, well, we could just say that if the creep image view .center.x is less than the current waypoint.x, then we take the new x value and we increment it by the move speed. And that's basically what we want to do. And that's also one of the reasons why we created new values, because we're actually changing this one, and we are still going through some tests where we're testing the center property. And if we use that directly, we would change it and it would mess up our tests. Alright, so it sees, well, if the center.x is less than the current waypoint, increments our value. Well, that's actually what we want to do for the center.x. We want to do it the other way around as well. If it's bigger than the current waypoint.x, then we just want to decrement it by the move speed. Now we have our x value settled. Now we test to see if the creep image view .center.y is less than the current waypoint.y. And if it is, we increment our y value by the move speed. And we do exactly the same down here. If it's bigger than the current waypoint, we decrease it by the move speed. Alright, and there we go. This should actually cause the creep to keep moving to the waypoint. But there is one problem here, and it's actually very hidden by this there. I think we're just gonna leave it here and I'll show you in a bit. Let's just finish this up. We're gonna test to see if it reached the waypoints. And that's just by saying if the creep image view dot center dot x is equal to the current waypoint dot x and the creep image view center dot y is equal to the current waypoint dot y value, then we call the next waypoint. And that's actually pretty self-explanatory. It's just testing whether or not our creep is directly on top of our waypoint. And if it is, we call the next waypoint, and it brings us in here, where it gets a new waypoint, which it can then start to move towards. Alright. And obviously we need to remove this line and then use our new coordinates instead. And we're actually gonna assign them here before we do the test, because these are new coordinates, so we need to move it to that point and then see if it's at the location now. And we set the center to CG point make, and we pass in the new x and the new y values. Well, let's take this for a spin, see how it behaves. I just want to rotate this again. Alright, let's see. It moves here, and it just gets stuck. It gets stuck now. It actually behaves kind of like we want it to, because we can see that it's starting at the right location, but then when it gets to this one, it's lagging, it's moving like this. It's like it can't really decide what's going on. And there's actually a way to fix this, because what happens is that if we take a look in our move method, we are using the move speed to determine whether or not we're close to, or we're using the movement speed to increase or decrease our coordinates. And if we go back to the game view controller, we can see that we set the move speed to 1.5. To 1.5, alright? Well, what does that mean? Well, that actually means that it doesn't really ever hit directly on top of the waypoint. It actually comes a little further than the waypoint, and then it runs through this method again, and it says, well, I went too far, I'm going back, and then it's too far back, and then it goes forward, and that's why it's keeping on going back and forth, back and forth. It's actually stuck. So we need to break it out of this stuck behavior. Well, one way is just to set the movement speed to 1, and that might fix it all, depending on whether or not our labels are exactly in place. But just see what happens there. Alright, well, it works. Does it go? No, there it didn't work. And you can see that this is really not what we want. It kind of works, and then again it really doesn't. And that's because values of these labels, they are not that straightforward. The center property can be anywhere between, it could be whole numbers like 10 and 20, and if it is whole numbers, well then it's great because then it would work. But if it has decimals, if its center property is 25.4, then we will actually never hit it. So we need to detect whether or not we are close to the waypoints. And we want to check for this after here. Now, it's just a simple if statement. And we check whether or not our creep image view center.y is equal to the current waypoints dot y, or fabs f creep img view center.y minus the current waypoint dot y less than equals self dot move speed. And we are just going to do exactly the same, the x value. We're just going to change y to x, x, and there we go. And if this statement is true, we set the new y value here to be the current waypoint dot y, and we set the new x to be current waypoint dot x. Well, this is actually a bunch of mathematics. What it does is to see, well, is the creep image view on top of the waypoint? It could be, it couldn't be, but if it is, we want to set this value. This is just a fail-safe, and it's not really the interesting part, but this one is. And this is an or. If the creep image view center.y minus the current waypoint.y is less than or equal the move speed, then we set our value to be exactly the one of our label, and it's the same as the x. If you want to examine this code, then you should try to print the result values to the inner log. But what it does is actually to see whether or not the center coordinates, they differ by an amount that is equal to the move speed, so that it should just be close to the waypoint, and if it is, then it sets this value to be exactly the ones of the waypoints, so that when they get set, they will be equal to this one, and they will get the next waypoint. Right? Let's take this for a spin and see how it behaves. Rotate left, play. See a small creep moving here. Well, and then it starts moving up. You can see it doesn't lag anymore because of the statement that we just put in. It just makes sure that it can differ by a small amount, and you can see our creeps are actually now moving along a predefined path. And that's exactly what we wanted. But it will most likely crash right about now. And why does it crash? It reached the last waypoint and then it crashed. Well, that's because we're doing this. We are not really testing whether or not this array is empty. Because when the creep's at the last waypoint, this array will be empty. So we just need to do a quick test to see if the, there we go, if the waypoint array count was less than or equal 0. It should never be less than, but never hurts to be safe. If it is 0, we want to remove our creep from the super view and then return out of this method. Well, let's see if this works. we have our creeps. Move up here. It's great. Then they stop moving down just around there. I'm just gonna pull into the storyboard so we can compare. And now it should reach the F and disappear. Well, what do you know? It works. Wonderful. And that's actually what we wanted to do in this tutorial. I'm sorry if I seem to be a little blurry. I made some mistakes, but it actually took me quite some time to figure out exactly how to make this waypoint system, so it's still a little new to me. But I wanted to share with you guys, and I hope you can use it for anything good. And obviously, there's a lot of changes you can make. But let's just take it for a final test. I have a map here. Just gonna import it in. And I'm gonna remove all these labels here. And I'm gonna make a map. Just drag in an image view and set it to be the map. There we go. We want our creeps to move through this path. Alright, we drag in our labels. Just label A, and we place it there, that's fine. Drag in label B, place it there, and label C, just around there, and D, E, F, and G, A, B, C, D, E, F, G, and H. You'll get really good at the alphabet by doing this. And now we just want to throw all these labels in here into our collection, which we have right there. So we can just do it like this. And let's take this for a spin, because now we've tried to add a map, we've added even more waypoints, but the behavior should be the same. Let's see about this. Well, what do you know? It looks great. And I guess this concludes the tutorial. And if you want to remove the flashing of the waypoints at the start, you just set on these variables to hidden, like this. Then they won't show up at the start. I'll just quickly show you how it looks like. And you can see we don't see that flashing of waypoints or labels, and now they just move. And that's actually what I wanted to show you guys, and I'm sorry that it took a little longer than expected, but I had to do a little more work on my waypoint system to get it fully functional. And again, I hope you learned something, and if you want me to send the source file here, I can do that. Just let me know on my forum, because I'm checking my forum down in the description a lot more often than I'm checking the YouTube comments, because everything's scattered on my forum, so it's easier for me to just put it all there, put all the comments there instead of at 15 different videos. But it concludes this tutorial, so thanks for watching, guys, and I'll see you guys next time, part 3 of the tower defense, where we will start to add towers. And I promise it won't take as long as it did from part 1 to part 2. So stay tuned, guys, and subscribe if you liked it. Throw in some comments and check out my forum if you have any questions at all. Thanks.